to make privacy programmable, we first have to dial back and kind of understand what do we mean by programmable and not programmable to begin with. What we have traditionally in terms of privacy is what we have pretty siloed and app-specific privacy to begin with. Think about like encryption and, for example, your Signal messaging app. Yes, things are encrypted, but it's very siloed into a specific application that is messaging. If we think about programmable privacy, then it's kind of a leap from the app siloed or the application-specific encryption or application-specific privacy that we have, and into a stage where we can now do general-purpose privacy over general-purpose use cases to begin with. The analogy or the analogy that I usually go by is think about the old ages of like electronics, where yes, we can do very fun things. For example, if we want to do a speaker, we can kind of craft a electronic piece to do, well, music attenuation or music production and getting sound out there with that specific electronic board. But then we kind of evolved from that electronic stage into the computing stage now, where we basically have computers to do general purpose computing over anything, including like music production and music stuff, as well as all the other things like maybe even controlling your lights, controlling, well, cameras even that we're shooting with. The analogy there then becomes like the wiring or the electronic circuits that we previously had were kind of similar to the encryptions or the app siloed privacy that we had before with hashing, with encryption. And now we have computers. We have zero knowledge proofs, we have FHE, we have MPC. These are kind of the primitives that enables us to do general purpose privacy, and that makes privacy programmable. For developers hearing about Noir the first time, there's surprisingly little that they need to actually know before they can actually code their first line of Noir. For me, myself, when I joined the team, I haven't even properly coded, for example, Rust or anything Rust-like before. Yet, it was super easy for me to onboard onto that entire process. The key thing I would say for developers to know would be how kind of zero knowledge proofs work from a high level and how privacy is achieved at a high level. By high level, I mean there's the basic concept of in zero knowledge proofs that there is the prover and then there's the verifier. These are usually different persons, different entities, different stakeholders to begin with. And when we talk about zero knowledge proofs for privacy, it's usually the prover proving things to the verifier without revealing, for example, any or not revealing any or most or the chosen part of the inputs towards what they are proving. And that kind of withhold from revealing is how privacy is achieved throughout that process. And basically understanding like the two entities of provers and verifiers is all they need to know before starting diving into more about Noir, before playing with Noir to begin with. What makes Noir or zkDSL fundamentally different to zkVMs when it comes to privacy largely boils down to, well, the fundamental differences between a zkDSL and a zkVM. For Noir or zkDSLs, what you're actually doing is basically you code your program, you code your logic at a high level. It then compiles down to, well, circuits or constraints that proving backends prove with. There's very minimal basically overhead in that process from your high level code to, well, the low level constraints that proving systems kind of interpret and use. In a zkVM approach, you are coding your program or your logic in a high-level language like Rust, like Python, whatever the language the zkVM supports. It then actually goes through first the zkVM itself. The zkVM itself is a ZK program that is written, well, according to the CPU architecture or the specific computing architecture that it targets. So your program or your logic that you coded with is an input to that zkVM, and that zkVM then generates a proof or it compiles down to further circuits and generates a proof of your program itself, a proof of your execution of the program itself. And so the main difference you can kind of see in these two architectures is that there is always the zkVM program in between what you are trying to do and what it actually gets proved by the proving system, where it is basically non-existent in the DSL approach or the Noir approach in this case. With that in mind, when we think about how do we do privacy in ZK, privacy in ZK always requires client-side proving to be achieved by itself. Going back to the prover verifier kind of separation, the prover would be generating a proof of something they know, of something they always have the knowledge of. And for that knowledge to not get leaked, for example, to the verifier or to the public world, then the prover needs to basically do the proving on its own machine, on its laptop, on its mobile phone, etc. And that prover is usually, well, the users to begin with. So that's you, that's me, that are generating our ZK proofs on our devices to interact with the app that we want to interact with. Given the unfortunate constraints or the computing constraints that we usually have on, let's say, our laptops or even on our mobile phones, or maybe we are the lucky ones, there are people that are using perhaps very hardware limited phones, very old models of phones even, that might not have a, well, good computing hardware to begin with. Performance is basically an equal sign to UX in that case when it comes to ZK apps. With that in mind, then the very minimal and lean approach of Noir gives you kind of the best performance out of the box to generate zero knowledge proofs to begin with. And that means exponentially better, basically, privacy user experience when it comes to privacy apps. That's something that the zkVM approach could eventually do, but also fundamentally, there's always the layer of kind of overhead in between what you want to achieve versus what it actually achieves. And that's today, in the foreseeable future, is just making things a lot worse when it comes to privacy apps with ZK.